Hey guys, welcome to our project, Chess Anti-Cheat. So first of all, a little introduction. My name is Osama Dabbousi. I'm a senior in data science, and I'm taking DS 598 with you all.
My name is Vishesh Jain. I'm a junior triple majoring in CS, Math, and Econ. I'm actually taking MS 51, but I am better than Osama at chess.
So let's get into our problem statement. Cheating in chess is incredibly easy. There are programs like Stockfish that play significantly better than humans, and it's really easy to use them on the side while playing a game. Cheat detection exists, but it's only for that superhuman kind of play. So if you play at a slightly above average level or just cheat a little bit, it's very hard to detect. There are companies like chess.com and Chess that have technologies for anti-cheat, but they're very secretive about them to protect their algorithms. So we wanted to use a solution that uses deep learning and revitalize the field. So our main question is, can a deep neural network be an effective anti-cheat? Can it detect this cheating? But an emergent question that came with it is, can a chess AI be trained to avoid detection by this anti-cheat? And so what that created was ChessGAN. So we created a generator, which learns to play chess and avoid the discriminator, and a discriminator, which distinguishes between human and AI moves.
So for the data, we took it from Chess's open database, where we took 50,000 human games that also came with the boards, the moves, as well as the optimal moves generated using Stockfish, which is a very common chess AI. The architecture we used was that of a CNN, where we had an initial convolutional 2D layer, followed by 6 layers that were taken from ResNet, followed by a fully connected layer that gives you the move, and a softmax that gives you the most likely move. The generator obviously takes in the board and gives you the move, while the discriminator takes the board and the move as a pair and gives you a prediction on whether it's a human or an AI. Here's the network for more detail.
So we didn't want to just try these networks. We wanted to try a number of different methods based off what we saw in our research. To begin with, we tried 2 loss functions. One was a standard GAN binary cross entropy. One was a GAN binary cross entropy that also had a categorical loss on optimal moves, meaning it incentivized the generator to play optimally. We also trained a baseline model that directly used the human moves to compare. And we used that model's weights as initialization for some of the models. So here are the results that we got. From what you can see from the basic GAN and the stock GAN values, they actually perform significantly worse than the baseline when trained just with the GAN loss and training. Not only that, but their KL divergence is high, meaning that they didn't even play humanly. But then looking at the pre-trained basic GAN and pre-trained stock GAN, what you see is that once you use those pre-trained weights, the GAN augments their level of play to play significantly better, winning 90% of its games against the baseline, while still maintaining an incredibly low KL divergence from the human distribution, meaning it still played very human-like.
So for the discriminator, we found that when given just unique board and move pairs, it wasn't able to detect if it was an AI or a human too well. However, when given sequences of such as lengths of 1 or 2 games worth, then it achieved very high accuracy. And this remained true even when the AI was guessing 40% of the human moves correctly, showing very good performance from the discriminator. On the bad side, the discriminator's ability did not generalize over AI. So for example, a discriminator from stock GAN and one from the basic GAN, they would not be able to discriminate against each other's generators. And finally, the discriminator also showed a memoryless property where we often fail to detect previous generators from a few epochs ago. We would like to show you how our best generator performs on a nice chess puzzle. Here, there's a 2-move checkmate for black. We can see that our chess AI does do the right rook move. Then after the forced move from white, black finishes off the game with a nice checkmate. We thank you all for your time and wish you a great day.
Thank you.